The objective is to find the electric field at any point from this dashed circle using Gauss's law. Now, first thing we need is the definition of Gauss's law. AdA will be Q enclosed over epsilon 0. So first we need to know AdA, what it is. By definition is AdA in magnitude times the cosine of the angle between E and dA. What is dA and the electric field? If I take this point M from this Gaussian sphere, radius of Gaussian sphere, and I want to find the electric field at this point. If the charge is positive, the electric field at this point will be outward. So this is the direction of our electric field at this point. Now let's say if I am here, the electric field will be outward. If I am here, for example, it will be outward. dA, this dA is the element of area. That means around this point, I will take the element of area, we call it dA. It has a vector, and this vector unit is perpendicular to that area. This is how we write dA, is the area times the vector unit that is perpendicular to that area and outward all the time. If I take this area for example, or anywhere, the dA will be outward. Okay. Now, what do we see here? This vector dA, which is dAn, is in the same direction as electric field. If they are in the same direction, means the angle between E and dA is 0. If theta is 0, means cosine of 0 is 1. This vector E times dA will be just E dA. Now I go and replace this on the Gauss's equation. What will be the integral E dA equals just the integral E dA, which is Q enclosed. In this case, the Q enclosed is the charge we have in this sphere. We say the charge is plus Q, so it will be just plus Q here, and we have over epsilon 0. The electric field, the distribution is uniform. The electric field, the magnitude is constant anywhere from that point, at anywhere from that circle. So this electric field, if it's uniform and constant, it will be outside the integral. It will be just the E integral dA. Now this dA is the element of area from Gauss's surface. Now if I add all these whole areas all around, the total area will be just the dashed Gauss sphere. Now the area of the sphere, the total area of the sphere, is just 4 pi r squared. So our electric field E will be Q over 4 pi epsilon 0 r squared. We said this will be just the integral ED. Now we are going to calculate the electric field due only to the charges that they are inside this dashed area, the blue dashed area. So the question is, what is the electric field produced by the charge inside this dashed area? And we want to find the electric field at this point. At this point, we call it R. So this is what we are going to do. Find the electric field at distance R, with the R is less than the radius of the circle. We consider the radius of the sphere, the non-conducting sphere, we call it R0. So the first thing we need to do, we use the definition of Gauss's law. So the integral of AD on enclosed area will be the Q enclosed over epsilon 0. This Q enclosed is only the charge that we have inside this zone. So anything that is outside the zone, where is the Gauss's surface, that is not included. Anything outside the Gauss's surface, it doesn't enter in these calculations. This is what does mean. The Gaussian area is just the enclosed area, which is this dashed area. So first we need to find the electric field direction and dA. If I take an element dA from here, it will have dA, it will have an area, I call it dA. The electric field produced from this charge from the center, it will be pushing in that direction, it will be E. The angle between this electric field and this element of area is 0. That means EdA equal EdA cosine of theta. This theta is 0, it will be just AdA. The electric field on this dashed area, it will be uniform and constant. The integral AdA, it will be just E integral of dA. And this is will be Q enclosed over epsilon 0. Now I need to find this Q enclosed. What is it? It means this Q that is inside this zone. Now remember at the beginning we said the density is uniform. What we mean by the density who is the total charge over the total volume of the sphere, or it is just the enclosed charge over the enclosed volume. The enclosed charge will be just total charge Q over the total volume V times the enclosed volume. The enclosed volume is 4 over 3 pi r cube. V, the total volume, will be 4 over 3 pi r0 cube. Now, what do we see here? The Gaussian area, the sum of all the elements of area of Gaussian area, it will be what? It will be the total area that you see on this dashed area. Is the total area. It will be just 4 pi r squared, and this is Q enclosed over epsilon 0. So we replace RQ enclosed with this. RQ enclosed, we said, is what? Is the total charge times the volume enclosed, which is 4 pi over 3 r cube, the total over 4 over 3 pi r0 cube. So we cancel these terms. We have is just the total charge on the volume times the cube of the radius of the enclosed surface over the cube of the radius of the sphere. Electric field E equals to what? Q enclosed, we said, is the total charge times r cube over r0 cube. This is Q enclosed over epsilon 0. They just replace this with Q enclosed over epsilon 0. And then here downstairs it will be 4 pi r squared. 1 over 4 pi r squared. Our electric field will be is a Q r over 4 pi epsilon 0 r0 cube. Okay, let's graph this electric field as function of r. Now, this is the radius of Gauss. This the electric field magnitude. Now, when r equals 0, electric field will be 0. Remember, Q over 4 pi epsilon 0 r0 cube is constant. So this function will be linear till when r equals when R0 equals to R. So our electric field in this case, it will be E equals Q over 4 pi epsilon 0 R0 squared. When the radius goes up, when the R is bigger than R0, then the electric field, we said in the first case, the electric field will be just Q over 4 pi epsilon 0 R squared. The electric field will be inversely proportional to the square of the distance. So this is the graph for this when R is bigger than R0. The electric field, it will be decreasing, is inversely proportional to the square of the distance. Once R equals to R0, the electric field will be Q over 4 pi epsilon 0 R0 squared. When R is less than R0, the Gaussian radius is less than the radius of the sphere, the non-conducting sphere, the electric field will be QR over 4 pi epsilon 0 R cubed.